What's up, everybody, and welcome to another episode of Harness Talk. No, not that kind of harness. Different channel, more popular. This one talks about wiring harnesses. It's Zach from Van Life Outfitters, and what you are looking at is the Wakespeed WS500 Alternator Regulator wiring harness. We have some secondary alternator power system bundles that are pretty incredible. Pretty much the best way to charge up your camper van reliably. And one of the things that trips people up when they go to install them is this wiring harness. So basically in these kits, you're gonna get an alternator like this one from Nations. This is a 12 volt secondary alternator. And you're going to need to regulate it with something like a Wakespeed. So Wakespeed is just a really intelligent alternator regulator that is designed to turn that sort of rotating alternator into a proper charging source. So what we're going to do is take a look at how you connect up the wiring harness to the Wakespeed and then walk through the different legs and connections. By the way, this is the so-called white version, or formerly white version of the Wakespeed regulator. As you can tell, it is not white any longer. It is now plastic, but it has the two RJ45 style CAN ports as well as the main harness connection. And so thus, the white version starting in around April, May 2024 is now a black plastic version, but still has the same connectivity. So the first thing you're going to do, of course, is plug the harness into the regulator itself with this large multi-pin connector. Let's talk through the other so-called legs. The first leg over here, this is the alternator leg. So this is, you can see it's pretty long, and it's designed to run from your power system area where the Wakespeed is located. So this guy goes with your batteries, your other equipment, and then this leg of the harness that goes to the alternator is pretty long because usually the power system, let's say in a van, is in the rear of the van, and of course the engine, where the alternator is in the front engine bay. Okay, so then over here, this leg is the so-called power system leg. And so this is much shorter because it's designed to be closer to the Wakespeed regulator, closer to the rest of your electrical components. Then we have this brown wire, and the brown wire is the ignition switched wire, typically. And we'll get into how you power the Wakespeed, but typically the reason that this leg is longer is it's also going to go up to somewhere where you can provide a ignition switched power source to the regulator. And that's so that it's not on all the time. It's so that it only turns on when you have power on this brown wire, as well as the main power that we'll talk about in a second. So in terms of how you connect this up, be sure to check out our free example wiring diagrams, which are super detailed. They're PDF files you can zoom way in to get information and detail. But let's talk about the alternator leg. Let's bring in the alternator again. Okay, so this is the Nations 12 volt 280 amp alternator that we include in our discounted secondary alternator product bundles. And it basically has three connections. So this one here is labeled B+, and this is a 5/16 inch lug where you're going to connect typically a very large 4-aught cable for the positive charging current output. And then the corresponding negative cable is going to be bolted on to one of the bolts that's holding the alternator in place. Then you have a green cable with heat shrink. Sometimes this color will change, but it's just a single wire with a butt connector. This is your field drive wire, or a field drive connection to the alternator. And then this connection, which is a black cable and a black connector, this is a temperature sensor for this alternator. So going back to the Wakespeed harness, you can pretty clearly see how this green heat shrink temperature sensor connector pairs up with the temp sensor on the alternator itself. This one gets a little more confusing, but we do detail it here and in our blog post. In this case, the blue wire is your field wire, and the yellow wire is the stator wire. With the Nations alternator, you're not going to have a use for the stator wire. It's not used. So what you're going to do is actually cut this gray connector with the orange plastic off completely, and that looks something like this. So again, we've connected this already to the temperature sensor, and then we've cut this connector off, revealing the two wires, a blue wire and a yellow wire. You're not going to use the yellow wire with this Nations kit, but what you're going to do is use the butt splice for the field wire that's coming off the alternator to the Wakespeed harness, which happens to be blue. So you would go ahead and push that in and crimp it, and that's the entirety of the so-called alternator leg. Let's move on to the power system leg, which actually has the most wires. We can move this out of the way. That, of course, plugs into the regulator itself. This blue heat shrink connector would be for a battery temperature sensor. And we highly recommend that you use CAN-enabled batteries that communicate through their BMS with the rest of your system. And typically when you do that, the temperature of the batteries is communicated over that CAN data network, and so this isn't used. If you're using a so-called legacy battery, something with, let's say, a lithium battery with an internal BMS that does not have data communication, then you would want another temperature sensor here that would connect to the positive terminal of your battery. So this is a temperature sensor for a Wakespeed, and you can see that the ring terminal would go on to typically the battery positive connection, not for an electrical connection, but just to understand the temperature of the battery. And then the other side would, of course, pair up with this connector. But again, we're not typically using this in the systems that we recommend because we'd like to see not just the temperature data, but lots of other data flow between the Wakespeed regulator and the rest of the system through the CAN network. And then the next set of wires on the power system leg is a green and yellow wire that goes to a gray connector with an orange interior. This is a CAN connection. It's a type of CAN communication connector that we're, again, not typically using in our systems. Instead, we're using that RJ45 network style connection. So if you have this type of CAN communication in your system, you might use that. In our example systems, you will not use these two wires at all. You can just coil them up and get them out of the way. Okay, the next set of wires are just bare wires. Again, power system leg. So start with the red and the black. These are your power supply wires. So the red wire should be connected to the same place, to the same fused connection as the output from the alternator itself. So in our example wiring diagrams, we show a links distributor, and we have that 4-aught cable coming to the links distributor to a fused location using a 300 amp mega fuse. This is connected to that same connection point. Because this red wire not only powers up the Wakespeed regulator, it also is going to provide the field drive necessary to drive the alternator. So if that fuse inside your links distributor blew, you would also want the Wakespeed to turn off. And that's the importance of connecting this power supply wire to that same fuse location at your circuit breaker, at your fuse, at your links distributor, what have you. And then the negative cable has a similar situation where you're just going to connect it to your negative bus bar. So these two wires are going to provide power. Now, this circuit should be fused at 15 amps. And a convenient way to do that is to wire in one of these type of inline fuses, where you can put in an ATC automotive type fuse that's rated for 15 amps. So this would connect through a fuse to your positive bus bar at the same location as the charging output from the alternator. The negative power supply would connect to your negative bus bar. Doesn't really need circuit protection. All right. Now, the white wire is the so-called feature-in wire, and it can be used in a really pretty broad set of ways. In our example power systems, we're using Victron equipment, using the Lynx Smart BMS, and the feature-in wire is a backup to CAN communication around the allow to charge circuit. So in Victron equipment, using external BMS batteries, there's a concept of allow to charge and allow to discharge circuits. So normally, the Wakespeed is going to be in communication with the system digitally. But if that fails, this feature-in wire is going to connect to the Lynx BMS and allow it to communicate to the Lynx BMS, hey, stop charging over this analog signal. So it's an important backup, and there is some configuration that you have to do inside the Lynx Smart BMS settings using Victron Connect. So again, all detail in our blog post. That's what this white wire is doing. So that leaves a purple and a gray wire. And these are used for a shunt, an analog shunt. That looks something like this. Okay, so if you're familiar with like a Victron BMV712 or a smart shunt, looks kind of like that, and it has the same purpose, but we call it an analog shunt because it has no circuitry built into it, no electronics. So this one has no Bluetooth, it has no, VE direct cable to communicate with anything, but it can do current sensing, and what you're going to do is splice on little ring terminals, basically number 10 sized ring terminals, and you're going to connect that with the purple wire being on the so-called input side and the gray wire being on the so-called output side. So if you imagine your alternator charging current cable coming in here to the input side, and then the output side is the continuation of that circuit from this shunt to your bus bar, that's what I'm labeling in and out. And purple and gray are going to be used in a corresponding way. Now, these should also be fused. So here's an example of another harness where we've gone ahead and spliced onto the gray and purple wires inline fusing. So we have a 5 amp fuse on both wires. And then on the end of those wires, we've crimped on ring terminals. And those ring terminals are going to connect up to the shunt on these terminal locations. Now, when you do this, you need to make sure that your Wakespeed regulator is configured to know that this shunt is in your system. And the purpose of this shunt is to monitor the current being produced by the alternator itself alone. Because you're likely to have, especially if you use one of our example systems, you're going to have a system-wide battery monitoring shunt that's going to show you aggregate, current coming in and out of your system. This one is designed just to measure and show you and report to your screen, to VRM, etc., how much current is being produced by the alternator by itself. And so that is what the purple and the gray wires are. So that is the extent, kind of all of the connections, if you will, on the power system leg. So the last thing is this brown cable, which we talked about briefly toward the beginning of the video. Well, what you need to do with this brown wire is run it to a ignition switched location. So one easy place to find that in a vehicle is usually the fuse box for the vehicle. And you can find a fuse location that's perhaps powering, like a cigarette lighter or a USB port, something that's going to be off when the key is off, and something that's going to be on only when the key is on. Because for the Wakespeed to turn on, to be powered up, you need voltage on this cable, or power on this brown cable, and power on the red cable. Okay, so this cable is really the power. So red is your power supply. The brown is just a trigger wire. So by running this to an ignition switched outlet, you can ensure that the Wakespeed is only going to be on, powered up, when that ignition switch is on. And when the ignition switch is off, of course, it's going to be off. You can go one step further and wire in a toggle switch on this brown wire circuit so that even if the ignition switch is on, you can still turn off this brown circuit and disable this entire charging system. Again, that's optional. But the important thing is you need power on both the brown wire and the red wire at the same time for the entire system to work. Alrighty, now let's talk about the communication wiring, or the CAN bus wiring in the system. So here's the regulator. If you remember, we have two RJ45 style CAN ports on there. In a Victron system, which is what we're going to recommend you use, you're also going to have a Servo GX, the brains of the operation. This is basically a tiny computer that is designed specifically for mobile and off-grid power systems. And you're going to have this thing called the Lynx Smart BMS. And so the batteries in your system are going to be controlled, monitored, and protected by the BMS. They're going to connect up here to these connections. But for now, we're just going to talk about this setup. So with your system, with your Victron system, you're going to need this, which is called a Victron to Wakespeed crossover cable. And it's basically, an RJ45 connector, but with different pinouts. So you have a blue side and a black side. So the blue side corresponds to the Victron pinouts for CAN, and the black side corresponds to the Wakespeed. So that's the crossover cable. The pins are going to be crossed from here to be compatible with the two different products. So you're going to take one of the RJ45 ports, doesn't matter which one, on your Wakespeed and plug in the black side, and then on the Servo GX, you're going to plug it into a VE CAN port. It's very important to distinguish between VE CAN, VE bus, and Ethernet because they all use the same RJ45 style connection. So VE CAN is here. Going to plug that in. So now we've created a communication between the Wakespeed and the Servo. Now we need to communicate between the Servo and the BMS. We have a rather short cable to do this. So we're going to take one of the VE CAN ports on the Lynx BMS and connect it to the other port on the Servo GX. All right, so we're getting somewhere now. So that was the VE CAN port. We're not using the VE bus ports. We're not using the Ethernet ports. Now, in CAN networks, you need to make sure that all unused ports are terminated. So in your Wakespeed kit, you would have received a black data terminator. You're going to put that in the empty port of the Wakespeed. With your Servo GX, you would have received a number of these blue data terminators. You're going to put that in the one unused port in your Lynx BMS. So this is the extent of the data communication network between these devices. And if you want to check out, why this is so important and the cool features of having these things connected, definitely check out our blog and look into our posts and our videos about the system, the secondary alternator power system, and a feature that's incorporated into this system called DVCC. All right, kids, that's it. That's how to work with the data communication and wiring harness. As always, if you have questions or you need to buy some of these products, be sure to check us out at vanlifeoutfitters.com.